first ever Valorant match. Wow. I'm gonna get this one-tap headshot, you know, establish dominance in the game.
Shut up.
Grudges, you and I were going B-side, right?
Yep.
Alright.
Is your flick shot good?
It was a little bit when we were playing. I was playing a solo with Grudges to kind of get a little bit. Dude, this bot phase is just toxic. Okay. I love this map though. That's the only thing, Grudges. You gotta give me some pointers.
Shoot people.
I want a real life survival
game.
game. I want to play a real life survival game like the Division 1.
I got the guy behind us. We're good. Move out.
Bro, did you remember Division 1, season like 4?
He shot through you to hit me. That's awesome.
Shot down. I have the spike. My ult is ready.
Alright, Grudges. It's just us here. You wanna chill or you wanna push? I think we're being lasered or like trapped, so I don't think we should push. Right here, on me. I'm reloading. Wait.
Last player standing.
I'm stuck in place. I don't know if I just died and took a minute, but like.
I'm gonna cut you here. Check it out. Yeah!
Never give up.
Yo guys, that's how you do it.
This is my first time
This
playing
is literally my first time playing as well, man. But I played CSGO before.
Bro, really saying.
I'm so hyped right now. I'm so hyped. I'm so excited for this game. I'm so happy.
Did you just get it?
I literally just got it right now. I got the key drop and then me and
Watching
Grudges.
streams?
Yeah. Well, I wasn't actually watching it. I was just basically watching the stream on, you know, like everybody else did.
Yeah, same.
Gone.
Enemy spotted.
Oh, I couldn't treat. Alright, I got him. I got the wall hack thing. I don't know if I think I killed him. Yeah, I did kill him through the wall. Oh, nice. I don't think he had a first.
Threw him in there.
Right here.
I'm falling back.
No more. Stay down.
Oh.
Dude,
On target.
you gotta come.
One enemy remaining.
Dude, what is happening? Oh my god, I feel like I'm...
Last player
This guy's so better
standing.
than me, though. This guy's always killing me. This is the good player, the Fire Scar. This guy always kills me.
Dang.
I got so many kills. I got 15 kills. I'm lying. Oh yeah, we gotta go.
My ult is ready.
Got him.
No.
Yeah.
There's
Silence.
one more in there.
On target.
Oh, our team's getting...
Bullseye.
Let's go.
One enemy remaining.
Clean.
Up behind me, so I got him.
No chance.
There's one more, like behind. There's one.
Bullseye.
How are you not dead? Okay, go to the teleport.
Enemy remaining.
Oh my god. They know I'm here too. It's like spawn.
Attackers win.
GG guys, GG.
GG.
But hey, we can't even see the scoreboard. It just went up that quickly.
Should tell us 27-16. 6-13 was the overall score.
I was top kills, not bad. Equip card, sure, why not? How do I go back to the escape? Econ rating, first blood, plants and fuses. Just KDA. Interesting, timeline. Oh, this got some cool stats in here. I'll have to check these out later. Well, there you have it, YouTube. My first ever Valorant game. Lost. But at least I was top frag. Okay. everybody, and welcome to CS302 Online. Good, not morning anymore, I guess, but good high noon, I guess. So, how is everybody? Everybody can hear me good? Everybody doing good? Everybody staying safe from COVID-19? Alright. So, that's good, that's good. So I was able to add in some more features. Now I can take a poll on Twitch, but I still gotta finesse it because I think you gotta put points. But then I can like ask questions in class and you guys can answer that way, and it might be better. Or maybe you guys can do the polls. I'm not sure. You're all alive and breathing. That's definitely a plus indeed. I'd say it's a big plus actually. All right, so. Let's see. You're going to tell me assignment 11 is the last program, so I have to squeeze in between the final project and doing other classes. Unfortunately, we still got assignment 12. And assignment 12 is that final project. However, I would say that assignment 11 is harder than assignment 12. And assignment 12 is easier, but there's more fluff to it. And by fluff, I mean there's more, like, the topic is Dijkstra's shortest path. However, the surrounding topic that I've wrapped Dijkstra's shortest path on, I think that might take you a little bit longer than actually coding Dijkstra itself. So there is indeed an assignment 12, and it is coming. It is coming soon. I will be posting it probably at the end of this week. I'll try to do it a little bit earlier, but I would feel much more comfortable having a solution myself before posting it, in the case that I actually get stuck in something. And then we will discuss if I will give skeleton code or not as well. But right now there's no skeleton code because there's no solution. I have the idea pretty well thought out. I actually did it on an iPad and kind of drew it out and everything. And I know exactly what I want to do. Now I just got to code it. So let's see. Do we have to use command line input for assignment 12? Because I miss being able to do my process in C Lion. You know, that's a big thing, actually. I don't want to spoil what assignment 12 is going to be because I think it's pretty cool. And I could change my mind still because I haven't told anybody, except one person who I asked advice from. There's certain level of interactivity that I wanted to do. And command line arguments was going to be one of the ways that you can set one thing ahead of time. I could also do this as a thing you could set up as the first thing when you run the program, so you could switch it to that if you really don't want to use command line arguments. However, I do believe in C Lion there's a way to pass in command line arguments, just like in Visual Studio there's the setting, or CodeBlocks++. So you might want to check that regardless of what I do, because in the future it might actually be useful to know how to do that. What is the final really? Wait, no, the final is not one question. This is the final project. The final is different and separate, and that's happening 2 weeks from Friday. Or actually, no, I lie. Technically 1 week from Friday. I don't understand why we can't use C-line. He can't use it because he says he has problems with command line arguments. But I think there's a way you can preset command line arguments in C-Lion, because most IDEs allow you to do that. It is not Star Wars, actually. The topic, I'll give you a hint. It has to do with games, unless I decide to change it. I had two ideas that was tied. I'll tell you the one that I think I'm not going to do. The one that I was going to do, and I'll probably save it for next semester, is going to be a Matrix video game where you're running away from agents, and the agents are chasing you using Dijkstra's shortest path, and you got to get to the phone line, the hard line, before they can catch up to you. And I could even go further and say, like, you can shoot the agents and they can shoot you. You can dodge bullets since it's Matrix. And it was really cool. But I think the other assignment's a little bit cooler. And I'll save this one for fall, because by then Matrix Movie 4 will come out sooner. So it might be more hyped that way to do it then. So that you can give a heads up to your folks who are taking Trio 2 during the fall. That's going to be their final project. Unless I come up with something better. And so here's the thing, though. You will have your final, but then you'll have that whole weekend and finals week, potentially at least part of that, to finish the final project. So I think it's better that way, because then you don't have to worry about the studying for the final. You can just focus on the final project once you've taken your final over that weekend. So yes, I don't know if Keanu Reeves will be proud of me until I actually make the code. And yes, you do have to study for your finals. I understand that, but I think you can allocate some time. I mean, obviously, you can get most of it done before even finals week. So we'll see. Will it be more than 777 points? You know, I originally was thinking of making it like 1,400 points, but since assignment 11 is pretty hard, I said probably potentially harder. I think that we might stick around the 1,000 point count so that they're kind of even, like assignment 11 and 12, and they're kind of the thing. Unfortunately, I cannot be bribed with the final. It will be as hard as it has to be. But let's put it this way. I will try to use the suggestion where there's only one upload for all your uploadable questions. And then there's other sections for like text questions. That way you're not uploading a lot of things. Because I think that was the biggest feedback some people were saying they didn't like doing that for the midterm. Skeleton code for assignment 11. There isn't really one that is, because there's so many different ways you can do the assignment. There's not much I could give you in the form of a skeleton code that would actually benefit you if you wanted to do it a different way. Because when you're creating your graph, you can do it with a JCC matrix, a JCC list, or with pointers. I think a JCC matrix is the easiest and best way to do it. Do remember that JCC matrices are better for dense graphs. And for sparse graph, you gain some efficiency with the HSCC list, but frankly, I think it's easier just to stick with matrix regardless. So that's the way that I did mine, and that's why in my solution example, I give you an HSCC matrix as an output. But there's so many ways to do it that there's no one skeleton code is not going to help you really for that. For assignment 12, on the other hand, the final project, I think skeleton code would actually help you, but I haven't decided yet because again, I need to come up with the solution first. There's no skeleton code if there's no solution. So anyways, those are what's behind, but I do want to announce one thing that's happening this Friday, kind of like a warm up or a teaser for the final. And that's, we have to do our ABIT assessment test. That's the evaluations that you get to do in all your classes probably. And at least all the CS classes, you've done them before, you did them in 202. And that's where you take a test, and it is within the scope of a final test, which means like it covers the entire class. And it's not for a grade per se, as in you don't get punished or rewarded for doing good on it. You just get points for doing it. Now, it's kind of tricky to set that up on Canvas that way because I actually want to use the Canvas grading to be able to keep stats of that for my report on that. But I will manually go in there and disable so that column doesn't count towards your final grade. I do think you should take that seriously though. It's going to be anywhere from 10 to 15 questions. Right now it's like 12, but I want to add 2 more questions to it, and they're all multiple choice. So that's kind of nice. And you get 60 minutes to do it. And yes, it is timed, 60 minutes. And that will be available for 12 hours this Friday. And you can use that, and I recommend you take that seriously because you can use it as a study guide for the test. And the solution will be available, I think, literally 1 minute after the deadline expires. It should make you be able to go and review your answers. And because it's multiple choice, you will know exactly what the right answer is because it'll highlight it. I don't think when you finish taking the test, it'll tell you whether what's right or wrong, but after the time happens, you will. Let's see. Damn, we're getting so much I like it. Lots of interaction. How can we grab your? No. Is the final going to be shorter than the measuring tool? Yeah. So I don't know about that, about the length of that. I will try to make it as short as possible, but I do have so much stuff to cover. And really, if you get extra time, that's mostly for logistics of just you saw uploading files and drawing things on Paint and things like that. I cannot compromise. I'm required by the syllabus of 302 to have an actual paper final. As I am required to have a quote-unquote final project. But I could just call assignment 11 final project. But, you know, that's not cool. We have to have a extra assignment. We actually are required to have 2 graph assignments. So we have to have a dexterous assignment, regardless if it's a final project or not. It has to be. Like, we have only done 1 graph assignment. And we need to have a second one. Just like we're required to have, I think, 1 hatching assignment. And 1 tree assignment or something. There's like 7 really hard required ones. A sorting one, I think, too. I have a list somewhere. I checked it. We'll meet everything as long as we do this one. Yeah, so people are planned. That's what I was saying. Some people suggested that you have one upload for everything. And so we'll do that for the final, where there will be one upload and you can just upload anything that requires an upload. And then, you know, you upload like 5 or 6 pages, whatever, and you number the questions next to the solution or the work you're providing so that it's easy to read. What do you mean 11 being final probably sounds cool? Yeah, but I have to have a dexterous thing, so, you know, don't worry. We'll work with it. But anyways, before we have to finish covering 2 main topics before we're done with the class for sure. We have to do what we're doing today, which is the second minimum span tree algorithm. And then next class, we'll be covering dexterous sort of span. And then that's going to take us to the end of this week. Next week is your final, of course. And so rather than doing like class on Tuesday and then review on Thursday, what I'm thinking is we will do a review on Tuesday and then we'll have class as normal on Thursday. That way the review is literally not a day before the test. And then whatever do that last day, if it shows up on the test, it will be extremely like superficial questions, which I have a couple of subjects planned for that Thursday, which is some algorithm analysis, P versus NP, and the SAP problem. And I highly doubt I'll ask you any of that on the test. But if I do, it'll be minimal. Oh, yeah, we're getting some internet errors. Hold on a second. Hold on. Give it a second. I can see your messages. Ad breaks? Wait, there's an ad break? It gave you an ad break? Are you guys serious? I was offline. Are you guys back? Okay. So I was getting 0 uploads speed. So my guess is that, welcome back everybody. I don't know what happened. I was just talking and I saw the spam on chat, and then I saw that my upload speed says 0%. So I'm assuming I went offline. Now I'm curious though. So it actually gave you guys ads while I was offline. You know, part of that is smart, but part of that is so sketchy because you guys are gonna think that I did it intentionally, but I did not. So yeah. That's hilarious that you guys got an ad. Well, I mean, yeah, okay. So if an ad plays, that is not my fault. I'm not doing anything. I am affiliate now, so I don't know. It's funny, but I'll probably get install AdBlock Plus. Actually, you should do that. You should always do that, and then you don't get an ad. But you got an ad for Buffalo Wild Wings. That's hilarious. But no, I didn't do anything. I went offline for a second, and I guess I decided to play an ad to cover up, like if I had done that intentionally. But that's hilarious, actually. I'm gonna have to like, will that even show up when I do the replay of the stream? I have no idea. But you can watch the video and see. But okay, that's really funny actually. But yeah, okay, we're back now. We're all good. So yes, I do not support or endorse Buffalo Wild Wings. The stream just crashed for me. That's funny, but yeah, I did not do that ad intentionally. Oh man, I can already see it in the student evaluations that during the final test discussion, he played an ad for Buffalo Wild Wings. Damn. Which, by the way, reminds me, student evaluations are now out, and I encourage all of you to go in and do them for me and for other of your classes. So please go ahead and do your student evaluations. You got on the link of the email, and then feel free to put whatever you want in there about Buffalo Wild Wings. Yeah, I think there is that subscribe thing as well. You get that emote or whatever, but I don't know. I was just setting things up as they came. But okay, all right. So let's just actually, that's the really bad if I go offline mid lecture and an ad plays. That's just totally gonna be like toxic. Do you want us to do the reviews? I do actually, and I do read them. I got feedback from the last time that you guys did them on the fall. I got the feedback at the end of December, I think, or beginning of January, before the semester started. and some of that was useful. The biggest feedback that I remember was that you guys didn't like the whole like assignment is due at like 555 and 666 and 777 and all those things. And so now all the deadlines are like 11:55, and I think that's working out. But if it's not, then you can put it under your evaluations. So I read them. I try to change things accordingly to that. The other thing was that the assignments, some of them were not super clear, and so I tried to talk more about them and try to help out more and be more clear about that thing. So I do 100% read them. I haven't never gotten anything super scary bad, so that's nice. I do want 3 a.m. lectures as well. That would be actually nice. If 80%, I checked about how much I can actually bribe people to do the evaluations, like in terms of like, can I give you points for doing anything like that? And I can't do any of that, unfortunately. Otherwise, I'd give you extra credit for doing them or something. But nope, that is considered like biasing people's answers, and so it's inappropriate. Who sleeps at 3 a.m. these days? Imagine sleeping at 3 a.m. in 2020. I mean, I went to sleep at like 8 a.m. and then I woke up at 11, and now I'm probably gonna go back to sleep at like 2 p.m. So okay, all right, we gotta get going to the material now. So because we have to finish covering this today. We are really on the following schedule, like I was saying. I don't know if this got cut off before the B-dubs ad, but today we finished minimum span trees and disjoint sets. And then next class on Thursday, Dijkstra. Then on Tuesday, review. Then Thursday, that's the extra lecture with P versus NP and all that stuff. And then that day after, you have the test. And don't forget, this Friday, you have to do ABET. And I think that's all the logistics that I wanted to cover. I have Canvas open here. You will get an access code for the ABET assessment test. And yeah, okay. That's pretty much it. So, okay. Did the stream stop for anyone else? Yeah, we're back now. So, okay. I should put that on Discord, make sure. Yeah, we're back up. We are back up. Do we have to do it multiple times if we have other classes, the ABET? Well, evaluations are different than ABET. Evaluations are like where you write your review about me. ABET is accreditation for universities to be able to actually be considered your degree to be like legit, and that's basically when you taking that test, and then I will, after the semester ends, I look at the test, I analyze the answers, like because it's multiple choice, I can very easily statistically say like how many people got this wrong and how many people got this right, and not just what right or wrong, but like what did they get it wrong for. Like if the answer was A and they all put B, then there's a sign there, and then I write a report saying like, okay, if everybody got the ABL question wrong, next semester I'm going to try to add an extra ABL day. If everybody got everything right, then I'm going to try to actually add more topics because we have more time. Things like that. So, yes. Yeah, that's... Linter subscribe with Twitch Prime. That's cool. That's like a first subscriber. Okay. Is UNOVCS program well respected? Because I hear we're tier 1 now. We are tier 1 as a whole university. As in like the entire university is considered one of the on levels of research, we're the best in terms of like of the tiers. That's for research. As for computer science itself, I don't know. Obviously, I'd like to think that we're good. We're obviously not the best, and there's room for improvement. But I couldn't tell you with honestly like where do we stand on those things. But you can probably Google it. So yeah, go ahead and Google it. All right, we have to. I know we have so many questions, but we need to start covering material. Otherwise, we are going to run late. And you guys you can ask more questions afterwards. So okay, so here we have disjoint sets. We're talking about Kruskal's algorithm today. Last time we talked about prim. So is that a yes? We do it for each class? I guess a yes for both. A yes for the evaluations, you should do it. And the ABET, I think any core class requires you to do it for pretty much all degrees, which means I think most classes you have to do something like that, not just engineering, as far as I know. But definitely for all the CS classes you do. Hopefully that answers your question. All right. I saved this here so that we can use it later. So one for each class for ABET. You should get at least for all your CS classes. If you're taking CS 219 right now, or I think it's the only one you could be taking now, you definitely have to do an ABET test too, and they'll make you do it. 301 they'll make you do it. In fact, I'm gonna upload that 301 thing at some point for you guys to do it. You should have gotten an email about that today. That I helped to draft together. Because Hall wasn't sure if you guys know how to use Canvas, but yes, for 301 you will have to do the ABET through Canvas as well. Everybody does it. It's just normal. 2019 ABET. They all should be multiple choice though, usually. Although the 301 is not actually. The 301 is 3 questions, I think. It's just essay questions, I think. Like I saw it very briefly. But anyways, don't worry about that stuff. Like I said, you just do your best, and it's not meant to as a grade for you. It's just an evaluation. So if you do bad, that's okay. That's good. That means that there's something to improve. So you just do your best in that. You obviously take it seriously, and you call it a day. And in this class, you can use it as a review for the final because it's a good way to test yourself. You have basically exactly a week from when you take this, the final list. So it's a good assessment of at least some of the topics. Obviously, it's small enough that not every single topic is there, but I try to put a question on each major topic, which questions whether you need to refresh that or not. So, okay. If very briefly we review minimum span trees. By the way, I re-uploaded the lecture for minimum span trees after we made that typo on the stream. So if you watch the Twitch one, that's the old one. But if you want to watch the corrected version, I re-recorded it that day, and that is on YouTube now. So you can go check that out, and you know, we'll see. So. Oh, that's cool. You get like a little thingy next to your name, Lintors, because you're a subscriber. Like, get that first. Okay, cool. So, okay. So last time, again, we did minimum span trees, and one of the ways that we found out how to do it was to make this little big table, which keeps track of things that are visited or not. I'm going to show you today how to do another method. But before I do, I need to show you what disjoint sets are, so that we can use the union operation on this second algorithm that I'm going to show you, which is Kruskal's. So now we're going to turn our head to the most 251, 351 kind of material that we'll see. And because I don't want to screw that up, I have it here on paper. And that is disjoint sets. Okay, so the first topic that we're going to be talking about today is disjoint sets. And the concept is easy, but a little bit of this is kind of abstract. So fear not. First of all, what is disjoint sets? Let me give you a off-the-book definition. I think it's off the book. It might actually be off the Geeks for Geeks too. I don't know. But anyways, it is a data structure that keeps track of a set of elements partitioned into a number of disjoint, there's that word again, which means technically non-overlapping subsets. So, yes. We have another subscriber for Prime. That's pretty cool. That feels weird. But thank you. You still don't get points on your test though. Okay, so that is basic definition of what a disjoint set is, which is to keep track of elements, and this is related to graphs most of the time, and we partition them into different subsets. Okay? You want an easy 12. Easy 12, I don't know. We'll talk about skeleton code. I just, see, until I code it and I get a feel for it, I don't know how hard it's going to be and how much I should give you, so you don't have to spend a lot of time doing everything other than the shortest path. But I have to code it myself. Otherwise, I don't know. I mean, I could think it's super easy and then I'm not thinking about one tiny thing. You know, I have to be able to see it. At least get more than 11. Yeah, because at 12 is very, very well defined. There's going to be like one way to do it, and or at least one very obvious way to do it that makes it easy versus like other weird, nasty ways. 11 is hard. I knew that 11 would be hard. I mean, it's just, that's why I warned you guys, like, because I was so super quiet over the weekend. Like, nobody was saying anything, and I was like, yeah, I think you guys realize that this is actually a really hard assignment, and it just the way it turned out to be, but and also because it's a hard topic. Graphs are hard. It's a lot of pointers, a lot of things that break. I mean, you saw Gucci had like, I don't know, like 200 gigabytes of memory leaks or something. Yeah. So, yeah. Okay. Yo815. Subscribe at tier 1. What is that? Oh, so that, wow. So wait, versus Twitch Prime versus tier 1. Does that mean you actually got scammed into paying money? Ooh, that's sad. Big F. Big F in the chat for actually paying money for subscriptions. Damn. Okay. So, we're going to come back to this. I just went ahead and put it here, but this is a little graph. Okay? We got 0, 1, 3, and 4. Okay? You need to make a subscriber list. Oh, you should try to use the emotes. I put in an emote for the subscribers, the Doc Kappa emote. Try it. Try using that emote. I don't know what the code is, but it's an emote. I'm expecting an emote right now. I mean, can I even do it? I don't know. You guys figure that out. But I uploaded a special emote. So, okay. And by the way, check out that article that was posted on the UNLV News. That's pretty cool, I think. And that thing that puts the UNLV department, CS department, in a good light. No, that's not the emote. You guys can't see it. It's, I don't know what the code is for it. I think it's like Sniper 166 or something that I got. Doc Kappa or something. It's the one from the CS. I mean, from the Discord. Hold on. Can I see it here if I look? Global. These are global emotes. I have no idea how to operate this. In fact, now, oh my, how do I even minimize this now? Oh no. There we go. Yeah, so I have no idea. You guys will have to figure that out. There is a special emote somewhere. Google it. It might have to be approved. Okay, so anyways. So we have the following graph, okay? 0, 1, 2, 3, and 4, and it's connected like that. And we're missing one more edge, which is that, okay? All right. So in our example, we can classify, you know, let me first tell you what a disjoint set is. If we have the following values, so or vertices, or just points, or whatever you want to call them, okay? A, B, C, D, E, X, Y, Z, we can signify the subset 1 to be basically A, B, and C. And because it doesn't matter the order, that's why we're using the curly brackets instead of the parentheses. If you remember the thing with like order versus unordered graphs, okay? And this is strictly just to understand what a disjoint set is and some of the operations that you can do on these things. So we have these three universes per se. The universe of ABC, the universe of DE, and the universe of XYZ, okay? And so these are disjoint, as in S1 and S2 are disjoint because nothing is shared between them, okay? If one of the ways that you can verify whether something is disjoint is by doing the following operation and seeing that it's empty, okay? And this is called the intersect. And this is 351 material or 251, one of those classes. Okay, so that backwards U is called the intercept. Wow, that's a lot of emotes. And so basically, if you do the intercept between two subsets and you get emptiness or the empty set, then that means that the two sets are disjoint, okay? Now, the opposite of the intercept is the union. So the union is like a U, which that's good because you can remember it means union. Just don't put the actual line of the U. More like a capital U. And that means union. And so the union of two sets, so for example, the union of sets 1 and 2 is going to be equal to basically both sets together. So A, B, C, D, and E. Okay? And just to prove a point here, the union of set 1 with itself would be just the same set. You don't put things twice. So it would be A, B, C. You only have to put one thing at a time, okay? So that's basically the two main operations that you can do, union and intercept. There's also like prime or what is the name of that? I think it's called prime. It's basically the not, like in logic, which means anything that's not. So if you think of like a universe, and then I tell you that this is set 1, then the not of that is going to be everything in white. So all of this. Okay? But that one's not really useful for us right now. So disjoint sets, since they have nothing in common. Alright, so there's that. Okay, so hopefully you get the idea of the union and intercept operation, because that's going to come in useful for us. So let's talk about the 2 main operations that you want to do with disjoint sets, and the ones that you would code if you were coding a disjoint set. And by the way, for assignment 11, if you really hate prim's minimum span tree, you may like Kruskals. And so if you decide that, the hard part about Kruskals is doing this disjoint set stuff, to be honest with you. There are ways around it, but disjoint sets is the most efficient way. So this might be the way to do it. So if you haven't finished that assignment yet, you may actually prefer to use this method. So we got union and we got find, okay? And so union is going to be the same union that we saw up here, which means take 2 sets and slap them together. So how would you look at that? You would write something like the union of S1 and S2 is just going to be the same thing that I had up here, which is just putting them together. Okay? So visually, I have a picture here. That would be like taking A, B, C, and taking D and E, and simply slapping the bigger circle outside. Okay? So that's going to be your union. All right. The other operation that you can do is going to be your find. So what is the find operation? The find operation is just going to tell you where a specific element exists, in which set. So if I say find B, then it's going to tell me S1 because S1 contains B. Obviously, although this wouldn't make much sense, SU union with whatever else would also return true, right? So maybe what would be better is if I said S4 is basically S1 union S2, then yes, I would say that find B would return S4 as well, okay? But that's basically all there's to find. So another example of find, if we said something like find D, that would be S2, find E would be S2, and find X would be, what do you guys think? Well, X is over here, so that's S3, okay? So relatively straightforward. Find just returns to you the name of the set. Union puts 2 sets together, okay? That's, theoretically at least, that's easy to understand, okay? So now, what can we use this disjoint set, union, and find for? Well, one of the biggest usages of it is going to be to find cycles in graphs, okay? So we want to be able to find a cycle in the graph. And if you can see here, there is a cycle in this graph. Obviously, I'm not talking about if I have a graph like this and it's undirected. Yes, you could go back and forth as much as you want. So in theory, it's a cycle. We're not talking about that kind of cycle. We're talking about cycles where you visit more than one node. So basically, if you visit this node, then you visit somewhere else at least, and then you can go back. So that's the smallest cycle you could have is 3 nodes. You cannot have a cycle with 2 nodes only. Okay? So this wouldn't be considered a cycle, just one edge here. So the goal is to write this algorithm that can detect cycles in graphs. And here we have this graph which clearly has a cycle, right? Hopefully you see that right there. That's your cycle. The top part doesn't have a cycle because 1 and 2 are not connected. There's no edge there. But this is definitely a cycle. So we want to find this out. And this is a hard problem. Like when you're looking at the obviously one of the ways that I showed you, if you have a GCC matrix, there's an easy way to do that. But if you're talking about like pointers and things like that, it's kind of harder to do, like a pointer implementation of the graph. And so how are we going to do this? Okay, well, I have the algorithm here, and I'm going to write the main pointers out. But then I'll go ahead and post a link. I think on Geeks for Geeks there's a good explanation to this. But what we're going to do is each of these edges that we have in the graph, we're going to make subsets using both the vertices of the edge being checked. So if both vertices that are being checked on each edge are in the same subset, then the cycle is found. And that's the heart of the algorithm. So I'm probably actually going to take the time to write that down here. So The idea is going to be cycle detection. Using disjoint sets union find. Okay? And so basically for each, that means for all. So that's technically the wrong thing. I think for each would be for with the E, but stick to not math. For each edge, so you're gonna run an algorithm that's gonna go through every single edge in your graph, okay? So for each edge in the graph, let's put that actually in G, we'll say G is our graph. Make them all subsets. Okay? No, sorry. No, sorry. You make each vertex a subset, not each edge. Sorry. Make that's our loop, that's our outer loop, code-wise. We're gonna make for each edge in E. Go ahead and make, in fact, let's put that outside. Sorry, I'm rewording this in a more clearer way than the way that I have it in my notes. Okay? Big G is equal to V comma E, which is all vertices and all edges that exist. Okay? So vertices 0, 1, 2, 3, 4, and the edges we can name them something like A, B, C, D, or E or whatever. Okay, cool. So first things first is make all vertices in G subsets of their own. Okay? You want to do that only one time. Yeah, okay, this is much cleaner this way. So make all vertices subsets of their own. So in this case, we're gonna have 5 subs. S1, S2, S3, S4, S5, okay? S1 has 0, S2 has S1, and so on, okay? Yeah, all right. So now, for each edge in G, so in those we have 2, 4, 5 edges as well. So we have 1, 2, 3, 4, 5. So for each of those edges, so that's a little loop that's gonna run 5 times. If both vertices are in the same subset, okay. For each edge in G, check if both vertices that are part of edge, well, let's give a name to this. For each edge called U, so we're gonna call U of each edge that we're checking, okay? So for each edge in G called U, check if both vertices that are part of edge U are in the same subset, okay? So yeah, that's gonna work. And then if they are, cycle found. Else, no cycle so far. Before you keep going, actually, union both vertices, or union both sets that the vertices belong to, and then keep going. Yeah, okay, there we go. That's the full algorithm. Okay, so let me go ahead and reread this, and maybe I'll try to clean it up afterwards to make it less messy. So basically, for each edge in G that we're gonna call U, so we're given the name of each edge U. We're gonna check if both vertices, we could call those V and W or whatever. We're gonna check if both vertices that are part of this edge U. So for example, if we're looking at, let's say that this is edge U right here. We have vertices 1 and 3 that are connected right there to edge U, okay? So we're gonna check if both of those vertices are gonna be in the same subset. And if they are, we have effectively found a cycle, and the algorithm ends and says cycle found, GG. Other way around is they're not part of the same subset, in which case we're gonna combine them into the same subset. by using the union operation. So for example, in the beginning, we say that the S1 has node 1 and S3 has node 3. And if we do the union of that, we can call the union whatever we want. We're going to call it SX. Is going to have 1 and 3 in it, okay? So at first we're going to check. We're going to see the different subsets. The identifier here doesn't matter. We're just saying they're different. After the union, they're going to be together, right? So in theory, we only check one edge once. But in theory, if we check the same edge twice, the second time around, it would tell us that there's a cycle, okay? But we don't do that. However, it will happen in this example here when we go ahead and we check both the edge from 1 to 4 and the one from 3 to 4. So I'm going to go ahead and move this away so that I get confused with the algorithm. But now we're going to actually run through the example, and maybe it'll make more sense, okay? And so here I have a sort of a cleaner version of that, unfortunately. That I wish I would have seen that a second ago. But the cleaner version of that is saying, so given UV, in this case, U and V are, instead of being an edge, now we're talking about their vertices. So we'll say they're vertices. If find U is equal to find V, remember, find returns which subset each item belongs to, each element. Cycle found. Otherwise, union. I put here X and Y. But X and Y are really representing the name of the sets. So I'll put it here. Both subsets. So take whichever one makes more sense to you. This one or this one. Okay? So let's talk a little bit about actually how do we implement such a weird thing. Okay? So the way you implemented it is you got your little fail. That's how bad of a rectangle I did that I thought it was a triangle. There we go. That's way too big. I think we went a little bit over the top here with the size of this. Can I see where the else statement? You can, this one, like that? Or are you talking about this one? That one? The other one. Okay, I'll show it to you in just a second. Let me redo this. So I'll do it up here while you copy that, and then I'll move it down. Okay, so there we go. Copy it. Go for it. Or clip that. Oh my gosh. That's horrible. I can't even do the rectangle. You go and get that else statement. Why is it doing that? There we go. Okay. So we're going to call this the nodes and the parents. And then we're going to put all the nodes that we have. 0, 1, 2, 3, and 4. Okay, you got it. Nice. Okay, and we're going to initialize all of these to -1. Okay, so now that we copy this, let's go ahead and actually move it down here since you finished taking a picture of that. And so we're going to initialize this little chart as such. Okay, and just to make sure, let me recopy. I'm gonna do it again to make it nicer. Our graph. So that's 0, 1, 2, 3, 4. There's an edge there, edge there, edge there, edge there, edge there. And do I want to put the circles? I'll try my best. They're not all the same size. I'm sorry about that. But at least they're circles. Okay? And actually, I like to keep track of it by putting E to all of them. Okay? It doesn't really matter what the weights of the edges are for cycle detection, so you can just throw them away and just remember that there are edges there. Okay? And so, how do we represent this? Well, the first step is make them all be sets of their own. So really, what is happening now is each of these are their own sets. So 0, 1, 2, 3, 4, and 5 are their own sets. And we can represent it by them all being separate from each other. Okay? Like that. All right? So the first thing we're going to do is we are going to go ahead and visit all the edges that we have. So let's go ahead and write down all the edges that we need to do. So I'm gonna write them down here, but it would be very easy to figure them out. Just basically all the E's that you have there, where are they coming from? Well, for example, we got an edge from 3 to 4, so we're gonna put it here. And I think that's it. We got the 5 edges there, from 0 to 1, 0 to 2, 1 to 3, 1 to 4, and 3 to 4. You could, of course, written this in many different ways. You could have written instead of 3 to 4, 4 to 3, exact same thing, okay? All right, so let's go ahead and start on the first one just because I put it there, 0, 1, okay? So again, the algorithm is to find U and V, so in this case, find 0, find 1, and see if they belong to the same set, okay? And so again, we are gonna go ahead and name our sets S0 to S5 per se or whatever, okay? So in this case, let's go ahead and do it. So find 0 is gonna give us set 0, and find 1 is gonna give us set 1. And so we're gonna check if those two are the same. Of course they're not, right? So because they're not, it means that they're disjoint. And the algorithm says if they're disjoint, then we're gonna union them together. So since they're disjoint, we're gonna go ahead and do union on 0, 1, okay? And so now the visual representation of that is like saying, and this is kind of trippy, 3, I'm probably gonna draw these nice ones and then copy paste them. So give me a second to draw them nice. 2, 3, 4, 5. And then let's just do this as well. Bear with me, guys. Okay, there we go. So we're gonna hook up 0 and 1 because we're doing the union. So how do we represent the union inside our little chart that we have here? Well, it's kind of like what we were talking about when we were doing the algorithm last class with the parent and the child and all of that. And so what we're saying is that, and the arrows can be a little bit misleading because they're pointing from child to parent, kind of like if this was a tree. So really, we're gonna say that the parent of 1 has now become 0. He has adopted 1, okay? And so if it confuses you to have the arrow going in that direction to signify parentage, then you can flip it, I guess, and you have to remember that. But ultimately, this is saying from 1, we can go to 0 because that's the parent and that's what's going that way. So you can think of the arrows pointing from the kid to the parent, okay? The child to the parent. All right? And so now that we have that, it's an easy way to check what is, that, okay. So basically, you can use it to check whether something is part of a subset or not, because you can follow the parentage to get there. So for example, if I want to see if 2 and 3 are part of the same subset, I look at the 2 and I try to go to the parents. The moment I see -1, that's my hard-coded value to signify that there's no links. But in the case of 0, I can go to 0 to continue to see that they're both part of the same subset. So if I said, are 2 and 3 that's part of the same subset? Then the answer is no, because 2 gets me to -1 and 3 gets me to -1. But if I was to check if 0 or 1 are in the same subset, I would see that 1 gets me to 0, which means that 1 and 0 are in the same subset there, and then 0 is on the it's going to 0, so that would tell me that 0 appears on both sides. So therefore, that means that there is a cycle, okay? But that's kind of going a little bit ahead. Before we get there, let's go ahead and take baby steps, okay? So we just checked one edge. There was no cycle. Now we're going to keep going, okay? So the next edge that we're going to see is 0, 2. So 0, 2 means find 0 and find 2. These, of course, are not going to give you the same one. They're actually going to give you find 0 gives me 1. And then find 2 gives me 2, okay? So because again, this is like one subset and this is another subset, and there is no connection between them. They're disjoint. Therefore, we are going to go ahead and perform the union of them to hook them up together, okay? So we're going to do the union of 0 and 2. or actually 1 and 2, because that's what we got back from here. Okay. How do we do that? Okay, so this is where oh yeah. One thing I wanted to say and I forgot. Just the same way that you can have the arrows this way, you can actually code a solution of this. Oh, that's not what I meant to do. You can code a solution where you use the other way around, where you actually make it so so in here the one that has the 1 is this one, and this one has a -1. You can do that. You can do a solution that actually does it this way, okay? If that makes you feel better. And actually, the reason I say this is because I am going to use that one. So you can use either or, okay? So, but you have to be consistent, okay? So if you do this version where you could say that the left side gets the right side or the right side gets the left side, both will work as long as you're consistent, okay? I just wanted to disclaimer that. In fact, I think we're gonna stick with the with the top one for the way that the one that I did here. But either way would have worked. Can you upload a new for 7-Eleven? I copied the PDF, but I'm scared something else might be put it in the method of the program. Okay, sure, I'll do that. I'll upload an input, I guess, Discord or something. But it should be just text, like. I know the PDFs can do weird things though, so fair enough. You can ask somebody from the 202 like 2 years that took with me a year ago. He totally there was a typo with the minus signs were being read as like weird dashes and things broke. Why does 1 point to 0? What I'm saying is either one of these will work okay. Okay? It will work okay to make 0 point to 1 or 1 to point to 0. What we're saying is that 0 and 1 are not connected. So you can make it one way or the other. You can make 0 the parent of 1 or 1 the parent of 0. I'm just saying both are valid and both will work, but you have to commit to one or the other, okay? It's pointing to its parent, okay? Because we union 0 and 1. And so you can make it like that. It's basically saying you can do it this way or you can do it this way, okay? Both are perfectly valid. Yeah, okay. They all should have a little arrow pointing to themselves, by the way. That's just a given, but yeah. Okay, so either one will work. In fact, we're gonna stick actually with making the other one around because that's the one that I have in the example, and I really don't want to dissuade from the example because I want to happen the thing that happened last time with the typo. So, been traumatized. Okay. Nah, one there, not 0. Okay, so yeah, all right. So now, when we say find 0, we can get 1 or 2. If we did the other way around, we would get 0, 1. Yeah, okay. So in this case, now we're checking whether 0 and 2 are in the same subset. They're not. 0 is in the subset of 0, 1, and 2 is in the subset of just 2. So they're not, so we're going to union them together. So the way that we can union them together is we can go ahead and hook this up there. And so we're kind of making like the hype train per se. Like that. Okay? So now all these 3 are in one subset and then these 3 are alone. Okay? So we're making a point to the parent. We're making this little chain. Okay? All right. So if we wanted to check, we would see that, for example, 2 is currently in the subset 0, 1, 2. 3 is on its own, and 4 is on its own. Okay? For find 2, will it be 1, 2? No, it would be actually 0, 1, and 2. Because you would look at the entire linkage of everything that would be there. Okay? So, does that make sense? Because 1 is pointing at 0, right? Because 1 is pointing at 0. Well, 1 is pointing to 2 at this point. If you did it the other way around, if you did it using this one right here, then in this case, I'll tell you what this one would look like. I just don't want to confuse you by having multiple things in the same page. But this one, if we did the union on that, this guy would be a... Oh, shoot. Should have been a 0 over here. My bad. And then so then updated version would be like that. Okay? like that one. So if this makes more sense to you, you can go with that method, or you can go with this one, okay? Either right to left or left to right per se, okay? So either one's okay. It depends on, again, which way you're making the arrows point per se. So yes, okay. So anyways, next we're gonna check the next edge that we have, which is 1,3, okay? So far, if you wanna see what we checked so far, we have checked 0, 1, we have checked 0, 2, and now we're gonna check 1 and 3, okay? So we're gonna check that 1 and 3. Yeah, 1 and 3 is the next one, okay. So if we're gonna do that, we would say that find 1 is gonna give us 2. And find 3 is gonna give us 3. They are of course disjoint, so we're gonna do the union of 2, 3. And so now the updated version of that table, again, it can look in two ways depending on which system you're using. But if you use the system over here, then all you gotta update is the 3 here. Like that, because this one's going left to right. And the other one here, you would update this to be a 2. Okay? So whichever method you're doing. I don't know which one you like more. Okay? So anyways, this is the same thing for 1,4. For 1,4 is find 1 and find 4. The union of that is 3, 4. Of course, that is going to be this edge. So we shouldn't get a cycle, but we will find out. I'm going to go ahead and copy and paste this again. Again, there's 2 ways to do it. We're just doing one of the 2 ways. So this is going to become a 4. Vice versa here is this will become a 3 here. Okay, whichever one you like. All right. Finally, we're gonna do one more edge, and I saved the best for last because that one should tell us that there's a cycle there, right? The 3 to 4 edge. If we do find 3, which is equal to 4, see right there, and if we do find 4, that's of course equal to 4. Well, those 2 are the same value, and when find gives us the same value, since they're equal, we have found a cycle. Vice versa over here, you know, if we went ahead and did this, then when you did find 3 and 4, you would find 3 would give you this, and this, and 4 would give you 3, and they would essentially both say that there is indeed a cycle. So either one of those would tell you that. Okay, it looks very weird, but I'm showing you just implementation wise. But I think if you understand the concept, you can figure out your own implementation. That ultimately, how else could you do this? You could probably use a hash table. The most least efficient way of doing this is to store it using an array. If you start using an array, then it would take n time to check every single time if things are in the same cycle or not. Because if you start using an array like that, then say you have A, B here, and you have C, D, E, okay? And you're checking whether the union of this has a cycle or not, okay? Well, if you're checking the union of this, you gotta compare this guy with everything here, and you gotta compare this guy with everything here, and so on, right? And so because of that, that's going to be a very, very, very expensive operation. If you do it with this weird algorithm, you can potentially get something like, not even n actually, you can get this down to, if you do it right, to log n time, which is much faster than doing it this way. So I guess the confusing part for me is when we did 1,4. When did we do 1,4? Oh, right here. 1,4 is saying find 1 and find 4. Find 1, I guess I can write it here the way that I have it, is going to equal 3 because that's that if we follow the train here, find 1 has 2 in it. We dereference that, we get to 2. Well, we're looking at this one up here. And then when we get to 3, we can see a -1. And when we see a -1 or we have nowhere else to go, that's when we can say that we've seen it all. So yeah, you see it. You see now the light. So there you go. That's a quick and brief introduction into Disjoint Sets. More of a math thing than CS thing. But it's useful because I want you to be aware of that's a thing. Because now we can use that for doing Kruskal's algorithm. You can of course use the ghetto version, like I said, with arrays. It's not as efficient and things like that. By the way, a lot of languages like Python have a union function, like a data structure, so that it can take care of doing these things like that. Just like they have a map, which is usually a hash table. But if you were to hardcore implement it on your own, you would go ahead and do that. But if you decide to use Kruskals and you decide to implement Disjoint Sets, you don't have to use this weird method, although it's pretty nice, I'd say. You can use the ghetto version of searching through an array or something like that. So, okay, Kruskals. So Kruskal is going to be another minimum spanning tree solution. Algorithm, not solution. It will get you to a solution. Let's go ahead and copy the same exact graph. Although I might use a smaller example now that I'm thinking about it. We can cut it now from there, because it might take us a while to do this one. So we're going to go ahead and try to find minimum spanning tree here. And by the way, why, now that we thought about, okay, Disjoint Sets are cool to find cycles, right? What is the advantage of knowing if there's a cycle when you're doing a minimum spanning tree? So what do you guys think? If you think back to when I first showed you the hand way of, like the easy way of doing minimum spanning tree, not algorithm way, but just kind of like the quick and easy way. Oh, by the way, I never brought the microphone down, so nobody told me about that. Yeah, now we're getting closer. So the easy way of doing minimum spanning tree was to basically remove edges from here, you know, until we didn't lose contact to something, right? That was one way to do it, right? The other way that you can do it is you can start with no edges and slowly add them back in, and then if as you're adding them back in you accidentally do a cycle, then you don't make that part of the minimum spanning tree subset. And if you do that, then you're good. You're basically you're in business. And that's basically going to be Kruskal's minimum spanning tree algorithm. So it's like, imagine I take this graph and I remove all edges. Okay, and as I'm erasing the edges here, I want you to notice something. Minimum spanning trees, there may be more than one for a graph. However, all minimum spanning trees share in common one thing, and that is that they all have the same minimum weight for the edges, which means if you add all of the numbers together of all the edges that make up part of the minimum spanning tree solution, and you get a value, which I think in this graph was 37, if you remember from last class, you will always get that value if there's more than one minimum spanning tree solution. You can never have one that's lower, because there is, then that would have been the solution for a minimum spanning tree. And if you get something higher, then that means it's not a minimum spanning tree. So if a graph has more than one minimum spanning tree, you're guaranteed that they will share in common the same weights. Now it's possible that if you add all the values together, there might be a different number of things, but like the values themselves, but the total of them added together will be the same. So 37 in this case, okay? So anyways, I went ahead now and I erased all edges. And what I'm gonna do is I'm gonna slowly add them back in, starting with the smallest edge, and only add edges that don't make a cycle. So as you can see here, one of the first steps in Kruskals is we're gonna have to sort the edges to be able to figure out what are the smallest. And so again, I'm just kind of showing you the example, and then I'll try to show you more of a proper example. But in sort of the light example, let's go ahead and mark the edges by colors just to see, you know, from lowest to biggest. So that's the lowest, that's the next biggest, these two are the next biggest. And then is there any 3s, any 4s? So here we got a 4. and so on, right? Okay, so that's more than enough. I think from there we can do the rest. So we're gonna go ahead and add the smallest weights. So that's 1 there. And then we're gonna add the 2s. And then we're gonna add the 4s. And so far we got, oh, we got one more 4 actually. We got this one. Okay? So far we've added all of the edges that are the cheapest, because that's the minimum span tree says that it has the lowest weight amount. So we want to add those cheap edges because they're the better ones to add. Okay? But as we add each edge, we're technically going to do the union function of the 2 subsets that we have here. So this for example is a subset, and this here is another subset. Okay? And as we add edges, we want to make sure that we don't create loops, because if we do the union and we find that they are contained the same nodes, it means we've created a loop. Okay? So anyways, what comes after 4? Any 5s? No 5s. Any 6? We have 1 6. That's here. Do we have any other 6s? No. So let's go ahead and do that 6. Okay. So here's a good one. If we add this 6, what we're really doing is we're going to check whether find 8 is equal to find 6. Huh, that looks weird. So find 8 currently has the nodes 8, 2, 5, 6, and 7. And find 6 has 6, 7, 6, 5, 2, and 8. Notice that they have the same things on them. Therefore, adding that edge would indeed be a cycle. So we do not want to add that edge, so we skip it. So so that you can remember that I skipped it, I'm just going to do like a thing like that. Okay, so we did not add that edge. Okay, moving on to the next possible edge that we can add. We got 2 edges with 7 on them. So let's go ahead and work on with those. So this one, let's look at the first one. The first one is we're going to try to do from 2 to 3, right? So we will technically do find 2 is equal to find 3. Find 2 has 2, 8, 5, 6, and 7. And find 3 just has 3 on it. Those are disjoint, you know. And because of that, we can go ahead and add that edge. However, if we were to try to add this edge here, you would find that find 7 and find 8 give you the same sets, which are this ones here, and because of that, they're not disjoint. So that would create a cycle as well. So we don't add that one in either. Okay, then we go ahead and do the 8. That's going to be the next number. And with the 8, something interesting is going to happen there. The same thing that happened before, right? Depending on which one we add first, it's going to basically create the second one that we add will create a cycle. So if we add, say, the top one, you know, find 1 is just going to give you 0, 1, and find 2 is going to give you 2, 8, 7, 6, 5, and 3. They're disjoint, so you add it in. However, if you try to add the second 8 over here, then when you add that, you're going to see that find 0 would have 0, 1, 2, 3, 7, 6, 5, 8, and find 7 would have the same thing, 7, 6, 8, 0, 1, 2, and 3. So that second edge would not be added. However, if I had done it the other way around, if I added that edge first before the top one, then the second one would not have been added. So those are the 2 possible solutions that we saw the same before, right? Okay, moving on. There are 2 ways again to stop this algorithm. One of them is to run out of edges, and the other one is that you have v-1 edges, because all minimum spanning trees contain, assuming that every node is there's a path from every node to the other node, that all minimum spanning trees will contain v-1 edges, because if you have 2 vertices, you only need 1 edge to connect them, right? So v-1, so 1. And if you have 10 vertices, you just need 9 edges to connect them. So at this point, we are at 1, 2, 3, 4, 5, 6, and we have 2, 4, 6, 8, 7 edges. So we need 1 more edge to be done. And so the next edge that we would add would actually be the 9. So that actually turns out to be the last edge that we will be needing for this. So find 3 is going to give you this whole big part, and find 4 is going to give you 4. They are disjoint, so you can go ahead and add it in. At that point, because you have v-1 edges, you can say that you're done. because you have 1, 2, 3, 4, 5, 6, 7, 8, and you have 2, 4, 6, 8, 9 vertices. So we have 8 edges and 9 vertices. We can say we're done. But suppose you did it the quote unquote dumb way and you did it until you ran out of vertices. You would see that any vertices that we add, such as this one, would create a cycle. This one would also create a cycle. And this one would also create a cycle. So none of those would get added regardless. And there you go. That is basically how Kruskal's algorithm works. Questions before I give you like some explanation on how to do this stuff. Well, okay. While you guys have questions, I'm going to go ahead and rewrite some of this down. Okay. But please do post the questions. Do I have the same graph as this? I do. Perfect. Okay. So I can just copy this. In fact, what's going on? Yes. You guys did not follow that example? I hope you did. This graph, by the way, is not random. I took it from Geeks for Geeks, so you can see. I think they run the same example there almost. I'm gonna take a picture of something. Hopefully, it doesn't explode like this whole thing. Document scan. No, it did not explode. You can't even see while I'm taking the picture. Interesting. Do you always need to use the disjoint algorithm when doing Kruskals? You need to use some way to detect whether or not you have a cycle. And so disjoint sets are one easy way to do it. But you can do anything like a ghetto array where you just keep things and you check whether there's a cycle. Any sort of cycle detection. That's the only part you need disjoint sets for, is for cycle detection. If you can find a way to do it without disjoint sets, like without the algorithm that I showed you, then you're okay. Okay, so I went ahead and added that in. That worked out really good. It actually looks super nice. Much better than what I would have done. Okay, all right. So what is this? This is this is not even an adjacency list. It looks like an adjacency list, but it's just cleaner. All it is I went ahead and listed all of the edges. So we have, for example, the edge from 7 to 6. Here, I'll highlight some of these. I'll color code some of these. Dang, we already have color coded this graph. Do we have a non-color coded version of the graph? Dang it, we do not. We can go up to last class notes. Maybe here we have one. Dang, we're so happy with colors that. Give me 1 second. Yay, here we go. So let me go ahead and copy this. I did see somebody posted a question. I'll get to your question in a second. What? Hold on. I forgot to hit copy probably. There we go. Okay, so the question was, so we just build the graph from scratch using the smallest possible edge, and if a cycle occurs using a given edge, don't use that edge. Yes, you basically have a one-sentence explanation of Kruskal's algorithm. I like to turn your graphs into smarter graphics when taking notes. Smarter graphics, I don't know what that is, but you do that if it makes it better. I have no idea. But this looks so nice. I want to use this graph in the test. Like, it looks actually a clean graph. But nah, because you've seen it already. But okay, so we have a graph here, and I'm going to color code some of these edges so you can see them basically. Because part of the algorithm says that we want to start with the lowest edge. The best way that we can kind of prepare that is to sort all the edges by weight. And you can use your good old trusty assignment 5 with a billion sorting algorithms, do quick sort or merge sort, and you can go ahead and do that in unlog n time, right? n in this case being the number of edges. So I'm going to color code some of these edges. So for example, this edge right here is going to be this edge right here. And then, for example, this edge right here, 401, is this edge right here. And then maybe one more. This edge right here is from 2 to 3. So that edge right there. And so on. Okay? So make sure to use the same values. Yeah. Okay. So, yeah. So basically, we take all the edges out of this graph. We print them in a list. We sort that list, and we come up with this right here. Okay? So once you have that, you then start working your way from the top to the bottom, because the top is the smallest edge. And then you're going to add these to your minimum spanning tree as they come, as long as they don't create a cycle. And for that, you can use the disjoint set. So, that's not what I wanted. Copy. Paste. So we're going to highlight all the ones that we think are part of the cycle. Or sorry, part of the minimum spanning tree, okay? So obviously the first one that you ever add is not going to create a cycle. So we're good on that. So we use yellow and we'll do it like that. Okay? Oh, there's another that. Okay. So 2020. So basically, we got 1, 7, and 6 is not part of the cycle. And then 2, 8, and 2 is not part of the cycle either, because if we want to consider, we have, right now we have 1 as a set, and we have everything else as its own sets. Sorry, not 1. I got to look at these ones. So we got 7 and 6 are now part of the same set. And then 8 and 2 are now part of the same set. Okay, with the next one, we would connect 6 and 5 into the same set. And then with the next edge, we will connect 0 and 1. And then everything that I have not listed here is in its own set as well. Okay? Then we will connect 4 and 2, or sorry, 2 and 5, which means that these two are now going to be the same set. Okay? So now we got 8, 2, 6, and 5. Okay? So sets are getting bigger. And look at this. We can do all of this without even looking at the graph at this point. We're that advanced. Okay. Here's the thing about the next edge, and I'll put it in different colors to signify its bad edge. For this edge here, 8 and 6 are in the same set. Because they are, and of course you need to find a way of checking this, whether it's disjoint sets or not. Posture check. Hydrate. Oh my god, you guys. I'll take some water. That's actually a good thing. Okay. And so basically, you guys are like my mom now with the whole posture thing. So that edge from 8 to 6 would create a cycle, so it's not going to be part of the minimum spanning tree. And so because of that, it will not be part of the minimum span tree. Okay? 2 and 3 here. 3 is part of its own edge, so now it's just going to be added to this one. Okay? So I forgot to dab. I did dab. I dabbed for you. There's another one. Okay. 7, 8. That's a good one, because now 7 is here and 8 is here, or backwards. I said it backwards. Those are going to get merged together, which means we're going to throw in. Oh snap! Why is 6 there? We can't merge them together then, I guess, because why is 6 on that one? That's kind of scary. We should have merged that earlier, I think. Yeah, that was in the beginning. When we put 6 together there, that should have been, the 7 should have been here. So that would have never existed there, which means we would have not gone and done this one. That would have been the first merge we ever did, because when we got 7 and 6 here, and then we did 6 and 5, you know, 7, 6, and 6 and 5, that would have merged them into 7, 6, 5. So I forgot to do that, but that's okay, because we did not run into any problems before doing that. Okay, so we're okay. So if you rewind on the video, you'll see that I should have merged that. So it's all good. Okay. So then we got 0 and 7. That was a good one, because 7 is over here and 0 is here. So now that's going to get merged, which means 0 is going to be added here. and so is 1, because that was the whole set, right? So that's a good one. The second 8, though, the 1 and 2, we already have the 1 and 2 here, so that is not going to be added. Similarly, with the 1 and 2 there, yet again, we already have a 1 and 2, so that's not going to be added. 3 and 4, we don't have a 4 anywhere, so that means it can get added here. So that's okay. 5 and 4, however, the second time around, that we already have. So that's not going to be added. 1 and 7 we already have in the same set, so not going to be added. 3 and 5, not going to be added. Okay? And that's pretty much it. You're very lost. Oh no, well that's not good. So again, we sorted this by edge, by weight, and then you start from the beginning and you start making your sets, right? So I'll do very fast again. What do the colors mean? Red means accepted. Yellow means yellow means accepted. Red means rejected. That rhymes, because basically it means that those would have created cycles, and so we did not add them. So we check fine. So I just went a little bit quicker, but so I'll do the first a couple again. So at the beginning we had nothing. In the beginning there was nothing, and then he said, let there be edges that are united. So here we have 7 and 6. That's going to be our first. So if you want me to, I want to try to do this in a cool way. So we'll do it one more time, because I mean at this point we are running out of time at this point, but we're basically done with it. This is the material right here. I do want to spend like 5 minutes comparing and contrasting Kruskals and Prims, but after that we're done for the day. So we're just about to finish. So I have enough time to do this in another cool way. So we have edges from 0 to 8, if I'm not mistaken. So this is going to be hardcore. You're going to like this. Very, very visual. Okay, so we got 9 edges. Do we have 9? 2, 4, 6, 8, 9? Yeah, okay. And we're going to run through this again, okay? So I'm going to have to make it smaller so I can fit it all in one page. Okay, so check this out. All right, so you're going to like this. So we're going to start by, this time I'm not going to highlight the unaccepted ones. I'm just going to highlight the accepted ones. And I'm going to use green because that typically people annotate that with okay. Seven and 6. That becomes a set. So we're going to circle it. Everything that's not circled right now, it's on its own, okay? All right, moving on. The next one, 8 and 2. So we're going to circle that. Okay, that's part of its own. 6 and 5. All right, we're going to circle that. Once we make a bigger circle, the smaller one disappears per se, but I'll leave it in there for now. Next, 0 and 1. Okay, that's going to become a circle too. 2 and 5. All right, because 2 is here and 5 is here, or vice versa, then those are separate sets, as you can see. Now they're going to become a bigger one. All right, so now we really only have 1, 2, 3, and 4 sets left. The big set with all the numbers, and then we have a set with 0 and 1, and then we have a set with just 3, and a set with just 4, okay? And then we find our first potential cycle right there, the 6, 6, 8, 6, because as you can see, the bigger circles are the one that matters here, and that's this one right here. As you can see there, 6 and 8 are part of that big circle. That signifies a cycle. That's when your find function would tell you that, however you implement it, okay? And your union is when I'm connecting things together. So you don't go ahead and add that in. 2 and 3, this one you can add in. At this point, I'm going to move things around so I can have the space for it. So I'm going to put that down here. And I'm going to put the 4 up here because it's still alone. And I'll leave the 3 there. So now I'm merging 2 and 3. So 2 is part of that big set and 3 is on its own. So then I'm just going to do it like that. All right, next we got the 7 and the 8. Again, they're part of that big massive circle that we have going on here. So because they are, we don't add that in because that would create a cycle. 0 and 7, that's a good one because now we're going to converge the two circles, the two bigger circles here. Oh, I touched the line. Like that. Okay. And finally, we need one more edge to finish here. And that's going to be this one. Because the 1 and 2 would create a cycle. Because we already added that. And so 3 and 4 would go ahead and merge it. So at this point, I'll just use this one. And now it just becomes one big ball. And because of that, everything else would not be part of it. So we should have gotten the same thing from both. We got a 0-7 there, and we didn't do it that one there. Sketchy. I think we just missed it on the other one. Oh, no. We would have gotten not the 0-7 here. No, we got on the... I don't know. I think we added this one we shouldn't have. I don't know. I'm trying to see which one is wrong. Well, you got the idea. We just made a mistake at some point because we got different answers. Let's see which one's right. Let's just count the edges we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, and here we probably have 9. 1, 2, 3, 4, 5, 6, 7. Yeah. So in this one, I think we just forgot to add this right here as an acceptable edge. We skipped that one. But the example that we just did is the correct one. So this one that we did, everything worked out. So yeah, there you go. Okay, pictures are always good, right? Okay, so that is basically Kruskal's. As you can see, it's actually easier than Prims, as long as you get the whole cycle detection part, which then makes it probably harder because that's actually tricky to figure out how to do, right? The disjoint set part. This is the first time that I teach them in this order. Before I always taught this version first and then Prims. So good experiment to see how people like it. So anyways, the last thing that I want to talk about is the pros and cons. First of all, let's do a little bit of an analysis on this. So the sorting part, as I said, you can do in nlog n time, right? But what about the whole running to the thing and doing the cycle detection? Well, I said you can do that in potentially log n time if you do it right, and you got n of these, so n log n time. So potentially, you can do this whole thing in n log n time, where n is basically the number of edges that you have. So e log e, right? And I think that's what I have up here. Yeah, e log e plus e log v. Why do I have the plus e log v part? E log v. E log v. I'm not sure. But what that means is you pick the highest one of the two. But, okay, so when you sort, you're sorting strictly by the weights. So that's definitely E log E part. So it must be E log V part when you're doing this. Oh, because you're doing it for V vertices, right? I suppose that makes sense. You gotta pick those. So I guess kind of in a way. But either way, E log V, E log N, E log X, Y, Z, whatever. Just E. It's still E log E class algorithm, right? N log N. So that's that one, and the other one was basically E log V, I believe. If you go back to the other ones, I have it on the top of the notes. So I have here both. Prims takes E log V, Kruskal takes E log V plus E log E. However, the E log V in Prims is if you use a binary heap, which I bet none of you are doing for the assignment. So technically, you're probably more around the V square land. So if you were to implement Kruskal, that's actually better and faster usually, as long as you don't screw up the disjoint sets. Otherwise, you're going to go to unsquared pretty quickly there. Okay, so the last thing, as I said, is I want to compare, and I have here, I got a nice comparison between both algorithms that I found on your guys' favorite website. I don't know if you can see that. You can't, but it says Stack Overflow. So, and it's cool because it actually has a pretty good explanation on that. And usually I project this. So I think what I can do here is I can probably just open it and show it to you. Yeah, I'll do that. I'll show it to you here on the computer, on the electrical device. Stack Overflow, Kruskal versus Prim. Yeah, that's first thing on Google. Right? That's the thing I said in that interview, right? We were all good at Googling. Alright, so let me go ahead and turn off the iPad. Okay, perfect. So I'll go ahead and post the link on chat if you want to open it yourself in case it's too small. But basically, and that's cool because now it's just on the YouTube as well. Use Prim's algorithm when you have a graph with lots of edges. So if you're dealing with a graph that is a dense graph, Prim is going to be a little bit better because remember, it's the same thing with a GCC list versus GCC matrix. A GCC matrix is much better for dense graphs because it's always going to be b squared within the GCC matrix. But if you're going to commit to that b squared, the advantage is that you can very quickly figure out if there's an edge between two matrices by just finding that intersect in your 2D array, versus the GCC list where you gotta look for things. So only with a sparse graph is when you even want to use this in GCC list in the first place. But here's this picture that I like. This picture kind of summarizes the algorithms, and so you can check it out on your own time to see the review of what's better. But anyways, here's the comparison that I like. So he says Prim's algorithm is significantly faster in the limit when you got a really dense graph with many more edges and vertices, and Kruskal performs better with sparse graphs because it uses a simpler data type. And so ultimately, I think that that's the best. I could not have thought of a better way to compare them. Okay, so really, and of course, it's this optimal implementation, right? If you don't want to mess with binary heaps, then you might as well just do Kruskals because Prim will be really bad. Vice versa, if you don't do disjoint sets correctly, Kruskals will be really bad, so you might as well do Prims. So pros and cons. But if you're picking everything nicely, actually, oh yeah, that's right. You don't even get the full optimization with binary heap. You have to use a Fibonacci heap with Prim's algorithm to really push the line, and he says it right here, right? So Prim's algorithm can run in E plus V log V if you use a Fibonacci heap, which you haven't even really talked about. So you have to use some hardcore stuff to really get the most out of the algorithm from Prim. So I'd say best way to do it is Prims with Fibonacci heap. And so how would you? I think this will end it with Fibonacci because I don't want to get into Fibonacci heaps. But anyways, that's pretty much it. That's all I got. So now all we got left is disjoint sets, and we're done. So now I go ahead and open the floor to questions before we call it a day. So any questions? Otherwise, we can dismiss everybody, and then we can kind of go into office hour mode where I can just answer general questions. Reminder: do your course evaluations and make sure you use that ABET test on Friday. I'll talk about it more on Thursday to remind you as well. And we'll talk more about assignment 12 on Thursday once I probably have started to develop the solution. So other questions? And then you get those points now. I could use the points to take attendance. It's like, how many points do you have? So questions? Anything? Which one do you like more? Kruskals or Prims? I can set up a poll. For assignment 11, is there an advantage using Kruskal versus Prim, or does it not matter? Well, again, if you're not gonna, let's put it this way, you're not gonna implement the optimal version of Kruskals or Prims probably, but frankly, Kruskals will be faster with the ghetto version that you probably implement. So I'd go with Kruskals. Hydrate. Why so much hydrating? Right? Remember, like to drown in water. There, I finished the bottle. Chug. I chugged the water. Oh, that's sad. The highlighting doesn't really work on the on this thing. It just works on the Twitch chat. So that's like a big time scan. All right. So here, I'm going to put up a poll on Twitch, and you can tell me which algorithm do you like better or you find easier to do. The choices are, of course, Kruskal or Prim. And in the test, I'm going to ask you to do minimum spanning tree, but you get to pick which... Oh, that's weird. I can hear myself if I open the stream. You can pick which one you want to do. So you can pick whichever one you want to do to solve the problem, but you have to explain whichever one you do. Oh, here it gives you the option to run an ad, but I'm not doing that. Manage poll. New poll. Okay. Kruskals or Prims? Kruskals. By the way, whenever I think of Kruskals, for some reason I think of Krusty Krab. And then Prims. And start poll. 1 minute. Alright, so I put up a poll, so let's see what happens. I'm not on your channel program. You know, I don't usually do much of the Twitch thing, but I was looking Twitch to watch to get the Valorant drop, and I saw people doing that kind of copy pasta about like, oh yeah, I've been a Summit fan for so long, I highlight all my messages and things like that. So did the poll work? Are we seeing results? View results. This is what I see. Oh, we can see it live. We got 3-4. Who's gonna win? This is so exciting, guys. Come on. We only got 3 to... I mean, I don't know how you vote. Yeah, I think you need channel points for it, or what? The poll is what's better, Kruskals or Prims? Oh, it's a tight race. We got like 4 seconds left. We got 1 vote to make the difference. Who's gonna win? Oh, and at the end it comes out clear. It seems like the winner is Kruskal. So you like Kruskals more than Prims. It ended too early. I don't know how to make it longer. Here, hold on. Oh, you can see what I see. So you can see there it says to run the ad. How do I? I can do the vote breakdown, but I don't want to do that because I feel like your vote should be private, you know, like democracy and things. I like that Kruskal can be described in a single sentence. Yeah. Yeah, you got doxception going on. Okay. If you do Kruskal, can we do that big circle example you did? Yeah, you could. I don't know if that's it. Frankly, I find the number version is easier. So let me switch back to that to see what I'm talking about. But that 1 minute poll is good because it keeps track of seeing who's actually alive to like respond quickly. I find keeping track of the numbers, as we did here, I erased a bunch of numbers, but when we kept track of the numbers together as here, is a lot better. But if you code Kruskals, you have to sort it. Yes, that's the one thing. But I mean, you know, actually, that's the one that, you know, that makes me want to do a Kruskals and Prims question, because then I could just combine this sorting question, but that's a little bit too much. So I think we'll put it this way. If in the test you decide to do Kruskals, you don't have to do the sorting, like to actually sort like bubble sort or like merge sort happening there. You can just sort them and then just call it a day on the sort part, because then I can check the sort part on the sorting part of the test. But yeah, imagine bubble sorting it on that question, and you're like, I ran out of time because I bubble sorted it or selection sorted it. Selection sorted is actually taking longer, more writing. So okay, well I kind of like the poll thing. I might do that from now on as a way to keep track of people, and if they're actually like awake. Yeah, and see how Kawa responds to sorting 1,000 elements. I mean, how are we doing on the assignment in terms of runtime? Like, anybody do anything weird and you have like super long runtime? I'm curious, especially with the traversals. Like, do you try running big numbers and push? I think I put it in the write-up. Push the limit and see how far you can go before like your depth first search traversal stack overflows or something. Push the limit. But all right then. Well, that's it. Any additional questions? I see nothing on Discord. Yeah. I wonder who that was. I'm such a saying that we deleted it before finding out. Push the limit, Crash Sally. Don't do that on due date though. Do that with a couple of days ahead of time. Or just run it in your local computer, you know? Because, I mean, you have those, you want to crash your computer too, you know? The pain must be shared amongst all computers. Why do I hear voice? Oh, it's because I have the stream open here. So let me close that out. I do definitely like the idea of having the polls. That's cool. I can do a watch party. I can raid. Interesting. Yeah, you did, right? Yeah, actually that's true, because when you're running it locally and you run it and you have that memory leak, that's pretty cool. Like I respect the 128 gigabyte, and that's like Call of Duty levels, you know, Warzone levels, and not CS:GO, but Fortnite levels back in the day. But all right, Prime Gang, I guess. Subscriber only chat from now on. Make you all pay to actually ask a question. that'd be so wrong. You're not gonna cover Dijkstress. I will do that next class. Dijkstress will take a long time, so we have dedicated Thursday for Dijkstress. But yes, that's coming in your future, guys. Dijkstress shortest path. You want to be here for that lecture because that's what assignment 12 will be about. So I want to make sure, and I'm gonna, you know, I'm sure as heck gonna run an example ahead of time to make sure I don't screw anything up. For that example, like I want to have it clean because we have no room for mistakes. You're gonna use student loans for tier 3. By the way, it reminds me, you should have got an email about the CARES Act. $11 million are being disbursed to students, and if you file a FAFSA, it will automatically be added. You get anywhere from $500 to $1,000. I do believe it's for the people that with the most needs, which are of course the people that most need it. But just make sure that you check that out and file FAFSA if you don't, because that you can actually be eligible for all these things. Check your Rebel mail. You should have gotten the email. It's titled something like CARES Act. CARES being that big $1 trillion packages they passed in Congress and President and all the people. It's a stimulus, and all you gotta do is do FAFSA, I think. And FAFSA, I don't know for what year. But I would just make sure you get it done make sure the last one is done, and then make sure you get the next year one done now, because you have your tax information already. If you file taxes or your parents file taxes and so on. But yeah, pre-record it. I don't know. I might pre-record an additional example with Dijkstress. I could do that actually. Then you have more than one, because Dijkstress will take a while to do. But we will do it on the same graph. We'll do it on the same graph. We like our graph now. We've gotten used to this graph. Deadline of like May 15th. Well, if it's May 15th, then you guys are still good for the deadline for the FAFSA then. So yes, get it done. If you don't get anything, the worst case scenario, the government already knows all that stuff about you. You're not giving them more information that they know. They already got everything. The NSA is the one organization that is always listening to you. Hi NSA. I will file my taxes before the deadline in July. Yes. I will try to do at least one additional example for Dijkstress without an audience where it's clean. Maybe I'll do that myself, and I'll wing it. Maybe I'll get it right. If not, I'll re-record it and I'll post that one. And then that way we have one good one, and then we'll do the live one too. Because Dijkstress, I mean, you got to get it right the first time. Otherwise, we're gonna waste so much time. 50% NSA agents, yes, each of us, yes. But anyways, we don't want to piss them off because I don't want them to raid my house or anything and take my computer. I need to be able to use it to teach. So, all right then. Well, 29 viewers that we have. Make sure you're here on Thursday. And I already said hello to my NSA agent today. He's very nice. He keeps track to make sure that my internet doesn't go down. Although today it went down for a little bit. So he quickly fixed things to get it back up, right? Apparently played a B-dubs ad. But, all right then. That's it, guys. We're done. Y'all can go. You don't have to stay unless you have any obscure additional questions. But otherwise, I thank you guys for coming. I guess thanks for the subs and all that. I really have no idea how this works. I'm not getting anything from this. You guys know that probably. Like the odds of me getting anything from this are super rare. I think you get like $100 before they even pay you out. So you guys are getting scammed basically for the money. For someone 11, is it okay if we output to a vertex 0? Yeah, it's okay. In fact, you should like you don't have to stick to the one. I just did what I did is I just have in my object. I did OOP because it's the best way, right? And I just copied the ID of the object of the input, which was a 1, and that's why you see a 1 there. But if you just want to keep the identifier as the name of the as the actual spot, then yes, you would have to print it out from 0. So yes, that's okay. All right, guys. Thank you all, and see you on Thursday. Be here or miss out. Cool. Nothing on Discord. All right. I'm gonna stop recording and I'll upload it. But I'll be on Discord if anyone has any questions. All right. See you all there. Peace out, I guess. I don't know.